Welcome to video 2 of the Nth Term by B-Dog's Maths.
Hey, B-Dog's Maths here, B-Dog again, and welcome to video 2 of the Nth Term sequence of videos. Pun intended. So, you now know where the Nth Term comes from, this sequence of natural numbers, and this video is going to help you about how to access that understanding into questions of sequences that go up or go down by the same number. They're called either linear sequences because if you track them onto a graph they would make a straight line, up or down, or they are called arithmetic sequence because to go from one term to another it's a system of an arithmetic thing, so it could be add 6 each time or minus 5 each time. So it's an arithmetic sequence or a linear sequence. For this, I'm going to jump to my computer so I can actually answer some questions with you, for you on the computer, so you can see that basic understanding of natural numbers and how the sequence can work from that, and how we access that into some serious questions. Alright? Just that simple. I say simple, it's a grade 4. But hopefully after this video you're going to find this very accessible and very easy, and you're going to be more confident when it comes to your exams. But if there are any questions, comment below, like the video, comment below, and then ask away, and I will do my best to help you, because that's what we're all about. B-Dog's Maths, see you in a little while, jumping onto my computer. See you in a bit. Hi there, as you can see I've put, shaking screen, as you can see I've put G4 at the top, which stands for grade 4, because that's what we're doing. And I'm about to show you my first question, so let me just get my mouse working. There we go. And the first question we're going to have is this one here. It's worth 2 marks. There we go. Zoom out a little bit so you can see it clearly. There we go. Worth 2 marks. Here is the first 5 terms of an arithmetic sequence. 6, 11, 16, 21, 26. Find an expression in terms of n for the nth term of the sequence. So in terms of this natural sequence that we've got, we know the natural sequence is 1, 2, 3, 4, 5, and so on. What can I call this sequence in relation to the natural term, in relation to the natural sequence? So my natural sequence should be 1, 2, 3, 4, 5, but this isn't. This goes up in 5s. The 5 times table goes up in 5s. So I can see that this sequence goes up in 5s, and it starts with the number 6. So that's also an important factor to think about. It starts with this number here, 6. My 5 times table should start with 5, but this one starts with 6. I put those two thought processes together, and Bob's your uncle, Fred's your auntie, you end up with your answer. My answer is just basically going to be the nth term equals, it's related to the 5 times table, so we're going to have 5n, but as the 5 times table starts off with 5 and ours starts off with 6, we know that this sequence is going to be 1 greater than the 5 times table, 1 greater than 5n. Therefore, we place this as 5n plus 1 to denote that it's actually 1 greater. And there you go. There's your 2 marks. Hopefully that was clear enough. Let's put another question up. Okay then, so here is another question. I look at it carefully, and the first bit, it gives me like a bit of like a teaser into the thing, so it kind of says to me that, oh, where's my cursor gone? There it is. That I've got 5 terms of a sequence, 3, 7, 11, 15, 19. It goes up in 4s. I know that. It does go up in 4s, which is fine. So it's going to be related to 4n, obviously, because that goes up in 4s too. This one starts off with 3. I don't like, my 4n would start with 4. So this is obviously 1 less than that. So therefore this is called 4n minus 1. So that's what this sequence is called. It's called 4n minus 1. And I've got to work out here the 8th term of the number sequence. And you can do that by just adding on 4 if you want. Fine. Or you can use your understanding of the natural sequence. The 8th term in the natural sequence is called 8. Yeah, as you know, because the 8th number as you count is 8. This is 4 times that natural number, and then take away 1. So I'm going to work out 4 times 8 and then take away 1. So that is the same as saying 32 take away 1. So my answer here is 31. Like I said, you could have just carried on through this, but if you understand the natural sequence and where this comes from, this will actually help you rather than being something that confuses you. Looking at this one then, write down an expression in terms of n for the nth term of the number sequence. Well, look at that. Because I've acknowledged what's going on up here, and I've already written this up here, I've actually already answered my part B question. So I'm just trying to show that actually, with understanding from that first video what's going on, you automatically put yourself in a far better position to answer this problem. The sequence goes up in 4s, so it's related to the 4n. It starts with 3 rather than 4, so it's 1 less than what I want it to be, so I write it down as 1 less. Alright, again, these questions all continue on this grade 4 format, same as here. This one here, you know, it goes up in 7s, so it's related to 7n. 7n should start with 7, but this one starts with 2, so that's 5 less. Okay, and so on and so on. Hopefully you enjoyed that video. It's very short and sweet, but that is how the nth term works on that level. Okay, just have a look at this one for me, but actually before we finish, here is a question. Here is a sequence. Now I'm going to change this question slightly, making it more tricky to test out understanding. So rather than having to write the nth term, we know the nth term to this. It goes up in 5s, so it's 5n. It should start with 5. It starts with 2, so it's minus 3 instead. We know that. We're okay with that. We're good at that. We're buzzing with that. But now I'm going to decide. Let me think. Is the number 421 part of this sequence? Is it? I'm not too sure. Let me think. If it is, then I know that I can take the sequence of 5n minus 3, and I should be able to find a counting number of n that makes 421. I should be able to do that if this is actually part of this sequence. Let me have a look. Let me just place my equal sign again. This is all, I'm circling this because I'm trying to show that it is, even though I'm thinking it might not be. If I remove this negative 3, so I'm just dealing with the 5 times table. In other words, I don't minus 3. I've added 3 on here. I'm going to have to add 3 onto this number too, which gives me 424. So what I did there is I added 3. If you're not sure about this, have a look at my solving equations video, or ask me to make a video if I haven't already done one by now, and I can show you how this process works. Then again, looking at my equals sign, to get to the counting number, I'd have to divide by 5. And here is where my problem lies. I can't divide this by 5 and end up with a whole number. No, sad. Can't do it, end up with a whole number. And because I can't get a whole number, it's proving that there is no counting number that will get me this number here, so therefore this number here cannot be in this sequence. Hopefully you understood that, because that is a common question. Is this number in this sequence? And that is one way of proving it. Okay, thank you very much. Hopefully you enjoyed it, and look out for video number 3 on quadratic sequences. Okay, thanks, bye. B-Dog is out. Oosh.
Once again, B-Dog waits for thee on video 3.